What are the two common pitfalls of recursion? One common pitfall of recursion is stock overflow. So each time a recursion function or a recursive function calls itself, it adds a new frame to the core stock. So this can actually lead to a stock overflow or even crash the program, especially if the recursion is very deep, like if it has a million or a billion calls. A good example of this is calculating the factorial of a very large number when you're using recursion without limits. So to handle this stock overflow, one might actually consider using an alternative such as tail recursion optimization. That is only if your language or your compiler supports it. So in the case of recursion optimization, the compiler optimizes the last recursive call. This will help to avoid adding new stock frames. Another common pitfall of recursion is inefficient performance due to repeated work. So in this case, most recursive functions have the same sub-problems that are run multiple times. So it's like they solve the same sub-problems multiple times. Doing this leads to exponential time complexity. For example, if you're working with the Fibonacci calculations, right, which have to do the same thing repeatedly. So to solve this or to avoid this and improve the performance, one might consider using a dynamic programming. So what happens in this case, the dynamic programming is used to build up solutions, right, from smaller sub-problems in an iterative manner. This is way faster and also totally avoids recursion.